So this is our mobile application, that is groundwater intelligence application, and we are bytecode learners. We have made this mobile application in which we have connected DWLR data, WRIS data, and CGWB dataset, which is provided on the government website. And in this we have this API, and we are just like using these APIs, all these present in these datasets, to show maps, graphs, charts, and use recharges, fluctuations, to help all the policymakers, government officials, researchers, farmers, and industrialists, as mentioned in our problem statement. So let's start. If we talk about the policy for the policymakers, like for example, recently if we talk about the Punjab floods, then like the policymakers don't have the exact idea like which specific place is actually like suffering from more water like problem, more groundwater level is high in which specific district of that. So our application would help policymakers in this. So nextly we have for researchers can export data to trend analysis, research, collaborate with other researchers in our application. Nextly we have for the government officials. If we talk about the government officials, they can get, if they log into our application, they can get one like critical districts, like in what areas is this like problematic areas, warning zones where the water level is very too low or too high. Like for example, if we talk about the Jaisalmer of Rajasthan, right, or Punjab Bathinda over exploitation. So they can get over here in our mobile application. Nextly, for the farmers, they can get the current groundwater level. Like for example, if I'm a farmer, I have to just open the application, and based on my location, I will get seasonal crop recommendation. That okay, based on your groundwater recommendation, like if right now I am in the place where water level is too low, so what it will say, avoid sugarcane or water due to high water requirement of these crops. Nextly we have it also suggests like water saving tips, like use drip irrigation. And nextly, if we talk about, this is our technical approach, and in this we will further be discussing about the UI of our application. And if I show, this is the user, government official, farmer, researcher, policymakers, and core user. For the technology, we are using mobile Flutter, and for the predictions, we are using ML predictions, so that we can predict the future datas. And for the cloud relay part, we are using AWS EC2 instance. Nextly, we have Firebase and database as a BAS backend service. And we have made this multilingual, because so that the local farmers can also like take benefit from this application. Nextly, we have provided dark and light theme modes. State management, like we have managed the state of our whole Flutter application using provider and river pod. Nextly, we have AR view. We have also like we are thinking of providing AR view to our application, in which the farmers or anyone has to just turn on his camera and go down, and he can actually see the actual water level in that area. And nextly, this is the UI that we'll be further discussing. Now let's move to the mobile application. So this is our mobile application, GWI Smart Water Monitoring System. So these are the different roles: farmer, researcher, policymaker, government official. We can log in as an anything, or we can also use skip sign. If like for example, if we are someone who is not one of them, we will also be providing a normal user, like who is not among four categories but is just exploring groundwater level. So they can also, let's start with skip sign in. But like if I am not signing in, so this is what we will get: dashboard, water level area, and full features will be available after login. So let's sign in to access further. Let's suppose I am a farmer. Then when I will log in, then I'll get your local groundwater, seasonal crop recommendation. Okay, these crops are safe to grow as per my current water groundwater level. Current groundwater level. Nextly, avoid growing. Like for example, if at my area the water level is very low, then avoid growing rice, sugarcane, because they require much water, right? Nextly, water conservation tips, like drip irrigation, apply mulch around plants to reduce evaporation, and many more. And even voice assistant and language change for farmers. Nextly, now we have like, if we log in as a researcher, then we can download any data, CSV data, like we have to just, this is the data of the last 7 days. But what we will be providing is, if it want, like we will be providing the data for all the, like we will providing a filter, like we can download the data of last 7 days, past 1 month. We have to just enter the date, like okay, just tell me about today's groundwater level. Then they can use that data, and they will also be able to download report, predefined format, beautiful reports for their research. And these reports will contain analysis, and analysis will come from machine learning predictions that we will be using. See, this is how we will be using predictions, research workspaces, and along with that we have like made research workspaces. It is like, for example, there is any research going on in IIT Delhi, then they have to just open, and they can like have a communication with all the researchers, and they can even contribute with them on the same data set. Now if we talk about the government official, let's say, so 3 critical districts, 8 warning zones, 15 safe areas. So this is how critical, warning, normal, current water level, monthly change, active alerts. This is how the government portal will look like. Now if we talk about the policy maker, so population, water security index, budget allocated, policy recommendations, schemes, and urgent interventions needed. So this is what our policymakers would see. So this was all about our application GWI from Bytecode Learners. Along with this, we will be adding a lot more features when we will start to build it actually using that data set. Then thank you so much. A very warm welcome.